All right, so I've set up a practice quiz for you guys on Delta Math, all right, which basically just comes from uh, the two assignments that we've had Monday and Tuesday. All right, but I do want to kind of go over some of these just for examples so that you guys can see how each of them are to be done. All right, so we'll just kind of start at the beginning, and I'll do one of each type. It won't take me terribly long to get through one of each type, and then we will. Uh, whoa, and then I'll give you the rest of the block to this one not going off the screen. There we go. All right, and then I'll give you the rest of the block to work on your specific ones. All right. So here we're just adding. All right, these don't really require any work, but just for demonstration purposes. So we take the real parts, -1, and we're adding here. So plus -3. So that would be -4. And then we take the imaginary pieces. So here we have 9i plus 3i to get 12i. All right, so here all we have to do is -4 plus 12i. Submit that, and bada bing. Pretty straightforward there. All right, so now we can go to multiplying. All right, basically we just distribute or FOIL, if that's how you remember to do it with binomials. All right, so we have 7 plus 9i times 7 plus 4i. So if we go ahead and distribute here, we will get 49 plus 28i plus 63i plus 36i squared. All right, now do remember that I squared is -1. So 36 times -1 really just becomes -36. All right, so 49 minus 36 is 13. And 28i plus 63i is 91i. All right, so that is all we have to put here. And voila, we are correct. Shocker. Okay, so now we'll go to dividing complex numbers. All right, so we do want to be careful with division here. All right, so we have 23 minus 11i over 7 minus 9i. All right, remember the trick to dividing numbers in complex, right? So all we have to do is multiply both the numerator and denominator by the complex conjugate of the denominator. So in this case, 7 plus 9i. Okay, all you do is change the sign in the middle. All right. Some people like to negate the whole thing. Please don't. That's not what we do. All right, so we go ahead and multiply here. So when I multiply across the top, 23 times 7 is 140 and 21, so 161. And then we have 180 and 27, so plus 207i. All right, and then minus 77i, and then minus 99i squared. And down below, we will have 49 plus 63i minus 63i minus 81i squared. All right, so here the plus 63i minus 63i cancel. All right, of course, I squared is -1, so -99 times -1 is positive 99, and -81 times -1 is positive 81. So we clean these up a little bit. 161 plus 99 is 260. And 207i minus 77i is 130i. And down below here, 49 and 81 are 130. Of course, this can be simplified nicely, right? 260 divided by 130 is 2, and 130i divided by 130 is just I. All right, so here we can say 2 plus I. Voila. All right, so now we can come down to plotting polar points. All right, so here it says plot the polar coordinate 5, 7 pi over 4. All right, all we do is move this dot. So we need to move it out to the 1, 2, 3, 4, 5th ring. All right, and then we need to go to 7 pi over 4. All right, now technically you're supposed to go 7 pi over 4 in the positive direction from that spot, all right, which is what we did, but it was just quicker to go backwards. But if you do have like a negative r, all right, then you do start in the negative direction, but you still like move in the positive. Okay, so do be mindful doing things that way. But plotting points, not terribly difficult. All right, so we're good there. All right, now we come down to plotting complex number in the rectangular plane. We did this yesterday as well. So remember, a plus bi, you just graph the point a comma b. So in this point, you're going to be graphing the point 5, negative 2. So 5, negative 2. All right, and then you come down here and submit. Pretty hard, right? That's a flat out free point on the test, on the quiz. If anybody misses that, I will fail you out of spite. You do not deserve to pass this course if you cannot plot a point. You don't even deserve to be in this class, to be quite frankly, if you cannot plot a point. All right. So finding the modulus of a complex number, all right? Remember, the modulus is just the same thing as the absolute value, or r, all right? So all we have to do is say, remember, r is equal to the square root of a squared plus b squared. So in this case, it's the square root. And do be careful, negative numbers must go in parentheses, all right? If not, you will get a very wrong answer, all right? So this is 49 plus 25, all right? So what's that, 74? All right, I don't think any perfect squares go evenly into that, right? 4 definitely does not, 9 does not, 16 does not, 25 does not. All right, we're good there. All right, so we can just write it, the square root of 74. All right, if you could simplify it, you would need to. All right. So here, finding the argument of a complex number in degrees, right? The argument is theta, all right? And remember how to find theta from going from standard to trigonometric. We know that tangent of theta is equal to b over a. So in this case, tangent of theta, all right, is equal to 3 over 0, which is undefined. All right, theta, tangent is undefined, all right, when theta is equal to pi over 2 and 3 pi over 2. So we need to figure out which of these we're using, all right? So if we were to graph this point, like we just did graphing, all right, 0, 3 would be up here. That is pi over 2 on the unit circle, right? 3 pi over 2 is down here. So we know that we're using pi over 2. Oh, I'm sorry, we're in degrees. So this would be 90 degrees. I do want to do one where it's not a nice unit circle value, so I will do another one of these. All right, so we have tangent of theta is still equal to b over a, but now my b is -9, and my a is 2. All right, this is not a unit circle value, so in order to get theta, we're going to have to do our inverse tangent. All right, so if we do that on our calculator, all right, we can do the inverse tangent of -9/2. We're in degree. You do want to make sure you're in degree mode, which I am here. All right, so theta is equal to -77.5 degrees. Of course, our directions here say that it needs to be between 0 and 360. How can I get a coterminal angle? Add 360. All right, so if you add 360 to that, you get 282.5. All right, now, all right, tangent is going to be will be positive. I'm sorry, this is negative here. All right, will be negative in two different quadrants. It would be negative in the fourth quadrant, which is where we are, right, 282 degrees. It would also be negative in the second quadrant, and of course they would have to have the same reference angles, right? So actually, if you just make this positive, that would be my reference angle here, right, which would be 77.5. So that means this would also have to be 77.5. All right, so if you take 180 minus 77.5 here, this would be 102.5. Okay, so now, of course, we need to figure out which one of these we want to use. All right, well, if we were to graph the original, right, we had 2, -9, so that would be down here. So I would be in the fourth quadrant, right, so 282.5. So 282.5 degrees. Bada bing. Okay. All right, so now we can go down to the argument of complex numbers in radians. All right, so here we were doing it in degrees the last couple of times. Now we want to do it in radians. All right, so it says express your answer in terms of pi. So again, we have tangent of theta is equal to b over a, right, which when 0 is in the denominator, this is undefined. All right, so again, theta is undefined, all right, at pi over 2 and 3 pi over 2. So which one of these are we using? Well, if we graph this point, 0, 4, that would be up here, which is pi over 2. So we just say pi over 2, bada bing, and we're good. All right. Let's do another one. Maybe they give us one that's not. Yes, okay, I like this one. So here again, we will do tangent of theta is equal to b, which is -9, over a, which is 3 square roots of 3. So of course this would reduce, right, to -3 over the square root of 3. So if you rationalize that, you get -3 square roots of 3 over 3, where these things cancel, so it's just negative the square root of 3. All right. When you do it, when it's in radians, it's always going to be a unit circle value. All right. So we just need to ask ourselves, okay, where is tangent negative the square root of 3? That occurs at 2 pi over 3 and 5 pi over 3. All right. So again, if we're going to graph this point, all right, I have a positive and then a negative. So I'm going to be down in the fourth quadrant, which is 5 pi over 3. Bada bing. All right. So now we can do polar to rectangular form. All right, so the directions say to convert the complex number into rectangular or standard form, which is a plus bi. Express your answer in simplest radical form. All right, so all we do is use our unit circle here to simplify. So we have 6 times the cosine of 210 degrees plus I times the sine of 210 degrees. All right, so we go to our unit circle, we say what is the cosine at 210 degrees? All right, so that's going to be negative square root of 3 over 2. All right, plus sine of 210 degrees is going to be negative 1/2. Of course, that's still times I. So now all I have to do is go ahead and distribute this 6. All right, so here I will get negative 3 square roots of 3, and this will end up being minus. All right, minus 3i. So that's all we have to do here. All right, negative 3 square roots of 3 minus 3i. Bada bing. Okay. So now we will do the same thing, but when we are given polar form in radians. All right, so now we have 4 times the square root of 3 times the cosine of 2 pi over 3 plus I times the sine of 2 pi over 3. All right, so we still have our 4 square roots of 3. All right, cosine of 2 pi over 3 is negative 1/2. Sine of 2 pi over 3 is positive square root of 3 over 2. Of course, we still have our I there. All right, now we go ahead and distribute this here. So 4 square roots of 3 times negative 1/2 is negative 2 square roots of 3. And 4 square roots of 3 times square root of 3 over 2. The 4 over 2 is going to be 2. The square root of 3 times the square root of 3 is going to be 3. 2 times 3 is 6, so this would be plus 6i. All right, so we will get negative 2 square roots of 3 plus 6i. Bada bing. All right, so now we go down here. Now we're going from rectangular to polar. All right, when we want to go into, when we're going into degrees here. All right, so it says convert the complex number negative 3 plus 0i into polar form. Express the angle using degrees from 0 to 360. You may round the argument to the nearest tenth of a degree if necessary, but you must express your modulus in its exact form. Remember, modulus is just r, and that is equal to the square root of a squared plus b squared. All right, which in this case is the square root of negative 3 squared plus 0 squared, which is 9 plus 0, which is 9. The square root of that is 3. All right, to find our angle, our theta, all right, we say that the tangent of theta is equal to b over a. This is just 0. All right, tangent is 0 when theta is equal to 0 or pi. All right, so to check which one that is, we graph this. Negative 3, 0 is over here on my unit circle, of course, that is pi. All right, so here we simply say 3. Oh, I'm sorry, we're in degrees here, so this would be 180 degrees. So this would be 180 and 180. But again, I would like to do one that has kind of some different angles instead of a nice unit circle one. All right, so again, we're going to do our r is equal to the square root of a square. That's going to happen again. Yeah, never mind. It won't let me. It gave me both nice ones. But we've talked about, and when we were just finding the argument earlier about how to use the calculator to find one that's not an exact unit circle value. All right, so rectangular to polar form in radians. So now we're talking about radians. So we still do r is equal to the square root of a squared plus b squared. All right. So when we do this, of course, this will be the square root of 9 plus, this will be 9 times 3, which is 27. So this is the square root of 36, which is just 6. For theta, again, we do tan of theta is equal to b, which is 3 square roots of 3, over a, which is negative 3. Of course, these 3's just cancel out. This leaves us with negative the square root of 3. All right, tangent is equal to the negative square root of 3 when theta is equal to 2 pi over 3 and 5 pi over 3 from our unit circle, of course. All right, so we need to see which quadrant we're in here. If we graph this, we go negative, positive. So I'm in the second quadrant. So that is 2 pi over 3. So this becomes 6 cosine of 2 pi over 3 plus I sine of 2 pi over 3. And voila. All right, so now we go on to multiplying and dividing complex numbers. All right, so here it says, given the complex number z1 and z2, express the result of z1 over z2 in rectangular form. So it's giving it to us in trigonometric form, but it wants our answer in rectangular form, which is standard form, a plus bi. Okay, so remember that z1 divided by z2 is equal to r1 divided by r2. I guess I should. Right here. All right, times the quantity of cosine of theta 1 minus theta 2 plus I sine of theta 1 minus theta 2. All right, so with our specific case here, I'm going to do 30 divided by 5, all right, times the cosine of, all right, and off to the side, we can just say, okay, well, 7 pi over 4 minus 7 pi over 12, all right, so we're going to need to find a common denominator here, which will be 12. So this will be 21 pi over 12 minus 7 pi over 12, which will be 14 pi over 12, which reduces to 7 pi over 6. So here we will have cosine of 7 pi over 6 plus I times the sine of 7 pi over 6. All right. Now, 30 over 5, of course, is just 6. All right. So this becomes 6, and now we need to simplify this. 7 pi over 6, the cosine of 7 pi over 6, is negative square root of 3 over 2. All right. The sine of 7 pi over 6 is negative 1/2. And of course, we still have our I there. So now when we go ahead and distribute here, we're going to get 6 over 2 is 3, so this will be negative 3 root 3. 6 times negative 1/2 is negative 3i. So negative 3 root 3 minus 3i. And where did I make a mistake? Oh, I did it again. Okay. So this is 30 times the square root of 3, not just 30. So this will then be 6 square roots of 3. This would be 6 square roots of 3. So I have to multiply both of these by the square root of 3. All right, so 6 square roots of 3, that's going to be 6 over 2 is 3. The square root of 3 times the square root of 3 is 3. So 3 times 3 is 9, and we have a negative. So this will be negative 9. All right, and then this will be negative 3 square roots of 3i. We've got the square root of 3. So it will be negative 9 minus 3 square roots of 3. Do make sure that you get your cursor outside of the square root when you hit I. Whoa, what? I don't care about that. Okay. I. All right. If you put the I under the square root, of course, it would be incorrect. Okay. So do kind of keep an eye on that. Yay. Okay. And let's go down to the last one. Actually, that was dividing. Let's see if we can get a multiplication problem here. Yes, okay. So here was a division problem. All right, so of course, z1 times z2 is equal to r1 times r2 times the cosine of theta 1 plus theta 2 plus I sine of theta 1 plus theta 2. All right, so in this specific case, all right, we are going to have 3 times 3 square roots of 2, all right, times the cosine of 7 pi over 12 plus pi over 6 plus I times the sine of 7 pi over 12 plus pi over 6. All right, so when we simplify all this out, this will be 9 square roots of 2. All right, this is going to be 2 pi over 12, right, if we get a common denominator. So 7 pi over 12 plus 2 pi over 12 is going to be 9 pi over 12, which reduces to 3 pi over 4. All right, so this will be the cosine of 3 pi over 4 plus I times the sine of 3 pi over 4. All right, so of course, looking at our unit circle, right, the cosine of 3 pi over 4 is negative square root of 2 over 2, and sine of 3 pi over 4 is positive square root of 2 over 2. Of course, we still have our I there. All right, so if I go ahead and distribute here, all right, the square root of 2 times the square root of 2 is going to be 2, and it's going to cancel with this 2. So this is just going to be negative 9. And here, same thing is going to happen here. So this is going to be plus 9i. All right, so here we should get negative 9 plus 9i. And we're good. All right, and our last type of problem is de Moivre's theorem, finding powers of complex numbers in trigonometric form. All right, so here it asks us to find this trigonometric number to the 6th power. All right, remember, z to the nth power is equal to r to the nth power. All right, and again, for visual aesthetics. All right, this would be cosine, all right, times n times theta, all right, plus I sine of n times theta. All right, so in this case, our n is 6, all right, so z to the 6th power in this case, all right, is going to be the square root of 6 to the 6th power, all right, times the cosine of 2 pi over 9 times 6 is going to be 12 pi over 9 plus I sine of 12 pi over 9. All right, you can just do this in the calculator. I think it's 216. Yep. So here we have 216. All right, times the cosine. 12 pi over 9 reduces to 4 pi over 3 plus I sine of 4 pi over 3. All right, and our direction said to express it in simplest polar form. So we leave it in polar form here. All right, so this is 216. This is 4 pi over 3. And this is 4 pi over 3. And bada bing. Okay, so that kind of concludes our demonstration today. All right, so we went over an example of every single type of problem that you're going to see. All right, so for the rest of the block, which you have quite a bit of time, right? You have 57 minutes. All right, that should be more than enough time to, finish this assignment, this practice quiz. Of course, if you get stuck on any type, like specific type, just go back and watch this video, right? I mean, and you'll kind of see exactly how it's worked out.